so far we have gone over cycle time, fixed time, and variable time. And when we discuss variable time, it's actually the travel time of the equipment, and it is a function of resistance of the vehicle to the movement. And the two time of resistance that we are talking about, which is rolling resistance and grade resistance. And we also use the equation for grade resistance and rolling resistance to determine the total resistance and effective grade in problem 1. And how we use this information to determine the speed of the equipment and the travel time of the equipment. So for that reason, we move on to the next. We use performance curve and retarder curve from the manufacturer. For any manufacturer, we'll have that for the equipment. And first, I just define in here for the two type of curve we are used. The first is performance curve, basically to determine the maximum speed overcoming total resistance. So in that case, it will be the equipment go uphill with the positive total resistance or effective grade, positive effective grade. Though the second scenario, when we go downhill, the effective grade or the total resistance is negative, and when the equipment with outbreak, we use retarder curve to determine the speed. So there in the slide, we also have that, but I just put it down here for you to see what is the curve look like from manufacturer. For example, this is the performance curve for Caterpillar model 631G, which is scrapper, and we use that for problem 2. But basically, with that curve, and they give you a gear, we need to know what is the gross weight of the equipment, the total resistance in terms of the effective grade percent. As you can see there, we can be able to use these performance curves to determine the available rim pull for the equipment and then the maximum speed for that scenario. Similarly, for the retarder curve, we do the same with the effective grade. With the weight, we can determine the maximum speed of the equipment can go when it go downhill, descent slope. So with that, we apply this in the problem 2 in here. So a 361G Caterpillar wheel tractor scrapper with the performance and retarder curve I just showed you has an operating weight of 105,000 pounds. So it's empty, that is its own weight, and operated with an estimated payload of 81,600 pounds. So that is the material loaded on the scrapper. And its performance and retarder curve shown in the finger here, retarder curve and performance curve. It's also available in the reference in lesson 3. So there is 3 scenarios: find the available rim pull and maximum attainable speed if it is operating on a total effective rate of 10%. So that effective rate 10% in this case, it will be positive, and you use performance curve. The second question B, if the equipment descend at 10% total effective rate, descend, it means going down, effective grade in this case negative 10%. Find the constant speed and gear range with the maximum retarder effort. So as you can see, B, we use retarder curve. And find the travel time if the slope in B is 2,000 feet long. So we have the speed in B with the distance 2,000 feet long. You can be able to find the travel time. So let's go to the first thing first. We need to determine what is the weight, gross weight of equipment. So we can have determine gross weight, and it equal to the empty weight, the weight of the equipment itself, plus payload, how much load that the equipment load on. And in this case, we have 105,000 pounds plus 81,600 pounds. So from that we have the gross weight 186,602 pounds. Then we, from that gross weight, we can go directly to A, and A, like I say, we can use the from performance curve, right? Apply from performance curve or chart. How can I use? So keep that in mind. We have that number, the gross weight, and effective rate 10%. So how can I use that to determine the available rim pull and maximum attainable speed? Go to performance curve. You start with gross weight on top. Gross weight on top. And it's 186,600. So it's somewhere there. And again, the about 1,000 as you can see. So from that, you go down vertically. Go down vertically until you get the effective rate. And in this problem, 10%. From that effective rate, 10% intersect there. Then you go horizontally. Go horizontally until you meet the performance curve. And then leave it there, that intersection, and continue to here. That basically the rim pull number. So that available rim pull. And from that intersection of the horizontal line to the performance curve, going down vertically, you will get attainable speed. So that one here will have us speed. The process will be similar in B. So with that, we can see for the rim pull, it's about between 15 and 20, so it's about 17,000 pounds, and speed between 5 and 10, close to 10, so I just say 8 miles per hour, the unit there. So from that, we can write down here for B, for A, so we have rim pull equal to 17,000 pounds. That answer. And then we have maximum speed. It will be 8 miles per hour. And that the question asks. So what does that mean? We can say that the machine will climb, ascend, right? Climb the 10% effective rate. What is effective rate? Go to problem 1. At a speed of 8 miles per hour. In 4th gear. Why 4 gears? 4 gears. Because they intersect at gear number 4 there. Just like you drive the car, which gear we get in. So gear 4. And of course, with the available rim pull of with available 17,000 pounds. 17,000 pounds. So that's what is about for the performance curve. Do similarly for the second scenario. We want the from the retarder curve, the equipment descent. Descent, it means negative. 10% total effective rate, 5 constant speed, and gear range with the maximum retarder effort. Then again, we can say from retarder curve. So by now, I suggest you to stop watching the video, pause, and try to figure it out yourself. What should be the speed in these scenarios? And then go back to this video and look at what I'm doing. But for continuity, I'm going to do here. So retarder curve for this one. And again, we still assume that in the same weight, which means 186,600 pounds full load. And we start in here. Again, go down vertically until they meet the effective rate, 10%. And go to get the retarder curve. Mark down there. And then when it retarder curve, whenever it meets, go down vertically. And whatever it meets there, that will be the speed they have. And in this case, as you can see, the speed is 13. Right? That is speed we want to determine, 13 miles per hour, as you can see there. So from that, we can have B here from retarder curve. We have the machine will descend the slope of effective 10% at 13 miles per hour in fifth gear. Why fifth gear? If you go there, they meet in the gear number 5. And that answered the question, constant speed and gear range that you see there. The last one, find the travel time if the slope in B is 10,000 foot long. So that should be travel time. So now, as you can see at the beginning of today's class, we're talking about travel time, but we cannot do that until here, the travel time. So travel time, as you can see, equal to, they give us the distance. We find out the V in B scenario. So just distance divided by V. In this case, distance 2,000 feet. So the V have to be feet per minute, things like that. But our V equal to 13 miles per hour. So you have to convert the unit, 13 miles per hour. And what to convert? We have 88 feet per minute over 5 per hour. Feet per minute for the unit conversion divided by 1 mile per hour. So from that one, we will have the travel time equal to 1.75 minutes. So keep in mind, we have to do the unit conversion as usual. And that then for this problem.